Don here in Florida, and today I'm going to answer a couple of questions from viewers, which is odd for me because I don't have that many viewers. Get interrupted. Number one from Marcus. Don, why do you suck so much? Why do I suck so much? Well, mainly because I have to siphon a lot. I have to siphon gas out of the motorcycle into the lawnmower, so on and so forth, things like this. So it's always good to suck when you need to siphon. Kevin, I would like to see more on the band speed reduction. Oh, the bandsaw speed reduction. Actually, I planned on doing this, and I'm going to do that today. That's a very good point. I brought it up in one of my videos that I had reduced my Craftsman wood bandsaw to cut metal, and I did that through the use of a starter motor, and we'll go ahead and show you that in just a minute. And three from Danny. Is that a BMW gas cap cover on your wall over your bench? Yes, it is. That is off a BMW, and that is a BMW painted on that gas cap cover. And the gas cap cover, though, does bring back a lot of memories, and it's kind of a tribute to a student I had. Some of you know it, some of you don't. When I left the military, I went ahead and got a job as a high school shop teacher, teaching automotive, welding, green technologies, different STEM type classes. And the main class, of course, was the welding and metal fabrication and the automotive technology. Those were the primary classes I did. And my first student, my best student, when I started my first year in high school, was a student by the name of Justin, and I won't give his last name out of respect to his parents. I don't know if they want this on here, but Justin was an extraordinary student, top of the line, last of a breed of real hardcore automotive type guys, and he just had the most promising future in the world. Went off, joined the Air Force, became an automotive technician, and shortly thereafter, a woman texting her on her cell phone did a left-hand turn in front of him, not paying attention, and Justin lost his life. And before Justin had left the school, he donated a number of his own cars to the automotive program there. One of them was a BMW, and when this had happened, when this had occurred, every kid in that school was broken up. And what I did was I kept Justin's cars for as long as I could as trainers, and each one of those cars we utilized different pieces for different things within the shop. The gas cap cover here, I took off one of the BMWs that he had donated to the class, and I put it over our intercom in our classroom, and every year I did a whole speech about safety, driving safety, and about Justin, so that none of those students would ever forget. So it was kind of hard losing Justin, and therefore I've always kept it up here, always kept it in sight within my shop, either at the school or here. I really miss Justin, so here's to you, Justin. Anyway, let's get on to Kevin's question here. We're going to go ahead and actually make or show you how to make a gear reduction for this case, Craftsman style, old style bandsaw. So let's do that. Okay, so this is the bandsaw in question. This is an old school Craftsman 12-inch bandsaw. I'd wanted a vertical bandsaw for a while, just to make quick work of some of the things around here when I'm working on projects. And the metal bandsaws that are available were kind of outside of my price range and size range. I just don't have any room in this garage. And what I got to thinking was a wood type bandsaw would work well, but none of them move slow enough to cut metal. So I started thinking about, in particular, the older Craftsman saw, because they have this cast iron surface here, which is much easier to work off of than an aluminum surface. It has the old metal casing, which makes it very stiff and rigid, and they're just very well built. And luckily for me, at the time that I was thinking about all this, I'd been watching the whole series of gear reduction or speed reduction, excuse me, by Mr. Pete 222 or Tubalcane, and he went through a couple different ways to do it, and then just basically threw up his hands and said, you know what, I'm going to go buy a metal saw, and that's what he did. And while all this was going on, I was still, of course, limited for space in the shop or in the garage here. This was what I decided to do. Get a wood saw, and my original thought was do the double pulley thing. And you know, I don't like having all these pulleys and belts running loose. And I was sitting there in my shop at work, and I had this starter off a Honda, and I started looking at it, and I thought, you know what, that has a gear reduction built right in it. So I thought, you know what, I took it apart, and sure enough, it had a 5-to-1 gear reduction. I figured out the difference in pulley sizes here, and I had these pulleys just laying in a bin over here in the garage, mainly from some modifications I'd made on the Craftsman lathe. If you watch my Craftsman lathe videos, you'll see where I pulled these out of. And everything just matched up right. I went ahead and took the Honda starter apart, modified it, used this as a gear reduction, and then I only have to use this one pulley set here, and it works just fine. Just like that. And the beauty of these automotive starters is that they have a planetary gear set in them, and they're very small, and the gears themselves are nylon, or they're nylon in Honda's case, and it makes them very quiet. And you may be questioning the use of nylon, but you got to figure a car starter needs to be able to put through about 3 to 5 horsepower, or mainly that horsepower is through torque. So that planetary gear set actually really does a good job of that, and it doesn't bust up. The planetary gear set in these starters is usually the last thing to go. So I have good faith in that, considering I'm only running a 1/2 horsepower motor. This should literally last longer than the saw. So let's go over here and take a starter apart and show you what you need to make this. And I'll go ahead and pull this off also and show you how I did this one. So let's go back to the bench and get that done. Okay, so I didn't have a Honda starter available to me. Don't let me lead you to believe that all starters will work for this application. If you ever go looking for a starter, you're going to find a few different styles, and what you want to look for is what looks like the Delco style with the solenoid up here on top. But in this Delco style, you're going to see one with a case that's long like this and black all the way down to this mounting point here. If it goes all the way down like that, black, then that doesn't have gear reduction in it. You want to look for one that has this area where it looks split, where it's 2 parts here and here, because this will be your armature area here, and this will be your gear reduction right here. And I haven't been into this starter yet, so I don't know what we're going to find. These are not hard to get a hold of. I went to the scrapper here locally and told him what I was looking for, and he's kind of a cranky guy. He said, well, you can look in the box in the back. And I went, and these were ones that they were sending out for rebuilders, and I dug around and found this, and this is off a Mazda. It was not supposed to have worked. When I tested it on a battery, it did work, so I don't know why it was in his scrapper box. But normally they should charge you about $8 to $10 for one of these. He just gave it to me because where I was working at the time, I was giving him a bunch of junk parts, so it was kind of like just one of those fair trade-off type things. So if you don't know a scrapper, or if you do know a mechanic, just ask around. These get thrown out all the time. The one off the Honda there, that was actually in the trash when I pulled it out. So yeah, they're not hard to get a hold of. All right, so let's take this apart and I'll show you what's inside of here, then we'll go from there. Alright, so there's the solenoid out. And there's the armature right there, and the brush is back in here. So move that out of the way for a moment. And then we can see down in here, these are they're not actually field windings, they're magnets. It looks like I lost a bearing here. I don't know where that came out of. Probably the end. There we go. And there's our planetary gear set right there. So let's see how that goes, right like that. Okay, as long as we got this off of here, let's check something. See, there's a cap, there's our brushes. All right, everything actually looks pretty good in here. This gear coming off the armature meshes in with the planetary gear sets. It's actually the sun gear. This is the sun gear right here. These are the planetaries. This is the ring, and they mesh in like this. Once we get them lined up, there we go. And what we want to do is we're going to want to see what the gear reduction is on this. So let's mark this so we can get an idea. So we're going to mark this red right here, mark it in line with that, and then we're going to mark this also in red so we can see how many turns we make on this. So let's take a look here. We want this to come right back to where it started. So there's 1, 2, 3, 4, 5. Okay, that's exactly the same as I had on the Honda, 5 to 1 reduction. So this shaft here would spin 5 times to every 1 time or 1 spin of the output shaft. So take this back apart. We're going to leave that all in place, but we have to cut this off of here for what we're going to do. And I'm going to take apart the one I've already got made and show you how that one was done. So let's go cut this off of here real quick. Alright, so that made quick work of that. So let's go on back to the bench. Okay, so back on the bench, we can push this out. I probably could have taken that out right from the very beginning. And I'm going to have to cut this off as well. We don't need this piece right here. So that's going to go back and get cut off too. And there's your actuation arm. And we're going to have to take this off. When we get done, we'll have our gear set here. I'm going to have to clean that up. We'll have our gear set here, and this will be off of there. This will be our output shaft, but we'll have to modify that depending on what we drive. So let's get this the rest of the way apart. All right. There we go. Oh my goodness, that was being a pain. And we can take all this off of here. And that's the carrier right there for the gears. So all this will stay together. So if we pull this, if we open this up, we can see that we have a machine surface right here. That machine surface rides on this bushing right here on the inside. And when I did the Honda starter, when I built that, I put an additional roller bearing out here, which was probably overkill. I didn't need to do that. So let's reassemble this back. So there's our planetaries and our ring, and then this will be the input gear right here. Now we have to get that input gear off. You can see how slow that output turns as I turn it. So with this free, we're good here. We're going to leave this alone for a little bit, and we're going to go ahead and we're going to remove this shaft from here. I should be able to press that right out. So let's go ahead on the press and see what we can do. Okay, so we're magically over here at the press, and we're going to see about pressing this out of here. Hopefully this will go easily and not give me grief. Let's see what happens. There she goes. Now I'll probably have to put a shaft in there to finish it off. Okay, I guess I forgot to press play on that last shot where the shaft popped out, but this is the shaft. It popped right out of the armature here, no problem. I just had to use a little extension bolt in there like that to get it down. So, and the need for this shaft is because we have to have the planet gear here, which is on the end of the shaft, so it goes in like that. And now we have an assembly that we can utilize, and this will of course go right down inside of here. Notice through the magic of video I've already cut this off, but this will insert down into here. Don't actually need that in there right yet, so that'll insert in there like that, and this will be our base that goes up against the saw, or anything you're converting or gear reducing, whatever goes against saw. It could be, you know, a drill press, whatever. And we're going to mill all this before we're done. And basically what we need to do now is we need to put a cap on here, and we've got these bolts here. We'll probably have to shorten these up because all this is gone now and our end cap is gone here. So we're gonna go ahead and make a cap that goes on here. And I'm one of these guys, I go online and I find bearings on eBay, like bolt sets for $3, and I'll buy up like, you know, 20 or 30 for $3. So I've got different size bearings here. The bearing that we use in the plate is going to be dependent on really what size pulley we put on there. If you got a 1/2 inch pulley, we probably want to make a 1/2 inch shaft coming off of here. And what we'll do is we'll just turn this and we'll press fit the size shaft on there that we need. And after that, if we need to, we could put a keyway in it or put a flat mark on it like that saw uses for a screw to go into. And that's how we drive it. On the output side, the shaft on this side would be modified for whatever we're driving. Now, I had to have this cut out here because on that saw, when I did it, I wanted this in close, so the shaft that it went into, it had a coupler, and you had to go in like this with your set screw to tighten up the coupler so you could drive it. So, but the Honda was actually a little bit more complicated. I had to put a center section in there, and that's where the extra bearing went, and a standoff. You know, it was way more work, that Honda starter, than this will ever be. This Mazda starter is actually going to speed things up quite a lot. So I've got different bearings here that we're going to use. This is going to have to get all cleaned up. I'm going to have to mill that. Let's go ahead and take the other reducer off of there and show you how that works. Okay, on this saw, to change speeds, I have to have a large pulley gear and a small pulley gear, and the larger here is driven 2 to 9, I think it is, and this is 3 to 7.5, and this will give me on the blade approximately 195 surface feet per minute and 400 surface feet per minute. And the pulley is just held on there with a set screw right here. Like that. And if we get down below here, this is why I need the cutout. If we look right up inside of here, you should be able to see a set screw right there. Let me turn it. Should be able to see that set screw right there, and that's why we need this cutout. So let's go ahead and get that set screw out of there. We don't actually have to get it out, we just need to loosen it so that this will come off. So a couple of turns ought to do it. All right. And then I have three Allen head screws, 1, 2, 3, that hold this all in place. Let me get it. So, and now I have to take the cover off because we have nuts on the inside. There we go. Oh, boy, I gotta vacuum that out. If we get a closer look in on this, you can see I bought one of these blade guides from eBay. There's a fella that sells them on there. These, I think, are a real good choice for the blade here. It controls it better. And because we're cutting metal, and that metal does tend to get stuck in the rubber wheels here, I went ahead and epoxied these toothbrushes. They're hard toothbrushes on here, and they don't get all the stuff off there, but they keep the majority of it off. So I think that helps a lot too. And if we look inside here, we have 1, 2, 3 nuts in here that I have to get off before I can take the motor. So let me get those off. Okay, now coming around to this side, I have the nuts off on the other side, but one thing you have to pay attention to on these saws is the curvature of the outside. They don't lay flat, so I had to make washers. I had to grind them the right size so that they would allow this motor to set flush. So I'm going to mark these since I'm taking it off. I'll red mark that one. And I'll blue mark this one down here. And that way when I put it back together, I'll know where the washers go. So, and that's about it. Let me take those washers off of there. And I'm going to take these holding bolts out. And you can see on this unit here, because I have a shaft that I'm going over, and this shaft has a, well, see, now I can't even turn it. Let me turn it this way. This shaft has a flat spot on it, so I had to make a hollow shaft here to go over, and that has the set screw in it that allows me to tighten up on there. And that's about it. This one here, this is a flat block on the bottom that I had to make because the starter only had 2 mounting points, here and here, and I needed to set it out a little bit more, so because you can see the base on this is fairly narrow, I had to set it out more. So that's what I did, was I put this flat block on there, gave me 3 mounting points. So on here we have a flat block, the original starter mount. This is the other block that I used to give me a little bit more space, and I have an additional roller bearing in here. This is the gear reduction set here. This is the outer block right here with the bearing in it. And this was actually the original end cap off the Honda starter, which I used as a bearing retainer. And of course this is the input shaft here. And that's just press fit over the original armature shaft right there. You can actually see the armature shaft in here. So let's go over on the bench with this and go over it one more time. Okay, I gave a brief explanation of how I set this one up. Notice I put a nice Craftsman sticker on there. A brief explanation of how I set this one up, and notice that with the Mazda starter, all this is pretty much taken care of for me. I can shorten up this shaft right down flat here and put my output shaft there, whether it has to be a shaft or a hollow shaft like this one. I have plenty of space in there to do it. So this is actually pretty handy. This one here, I was expecting more grief out of this, but I'm not getting it. And then of course the input shaft here, I can do whatever I want with this. This is going to go through a bearing like this. It's going to go through a bearing and a outer cover right here like this, and I can turn this into whatever I want, either by pressing a shaft on or a coupling, whatever I want. So there's a lot of options here. So let's go ahead and stop right there. Okay, I guess that's going to about cover it for today. It's getting really hot out here. We're going to have to go into cutting some metal and doing some milling and some other stuff, and it's just too hot right now. So we'll go ahead and probably do this in 2 parts. We'll see how it goes in editing, and do all the milling and assembly in the second part. And I don't know if I'm going to set it up to actually run on that saw or not, because this is basically a demo. And I think everybody kind of gets the gist of where I'm going with this. So I guess that's it for now. And again, and as always, from Florida, Don out.